Module 3, we brought some explanatory pictures, and you shall learn about safety measures and pipeline construction phases with self-explanatory pictures. This is to help you to work, but to understand the overall if you have less experience at site, so this might help you. If there is a incident happening or accident happening or an injury report form where it happened, you should always make a concise report, an accurate report of what happened. Take as many pictures as you can, when it happened, what was the cause, probable cause, and the time and location. Confine the space. If means you anything that you have difficulty entering or exiting, that's called a confined space. So it doesn't mean that it's enclosure. It can be a trench, it can be excavation. That's also a confined space if you have difficulty accessing that place. For example, you need a ladder to get in or something like that. And before entering a confined space, you should always do a gas test to see there is no harmful gases there, although it looks harmless, because many dangerous gases like H2S and all, they're like odorless, and until you're not down, you don't feel it, and by that time it's too late. There are many fatalities because of not doing the gas test. If you cannot remove the gas or clear the harmful substance, then you need to go with confined in a confined space with self-contained breathing apparatus. As you can see, this guy is going through the pipe with a SCBA, and so you see here how the pipes have been stored. You can see that not more than 5 pipes are stored on top of one another, and there you can see there are some strings here, so that to separate the pipes, so the pipes do not touch each other and there is no damage to the coating of the pipes, and so they're not like grudging against each other. And then they should be on a raised ground, so they're not flooded, and you can see here that they are on a raised ground, and also there is a tarpaulin that's spread under them. Normally they say you should close this, but then there are too many pipes in the yard, so it's not possible to close all of them. You can also see that around a few inches from the tip of the pipe is not coated. That's done during the field coating, because you cannot coat, you cannot weld on coating. So when the tie-ins, the pipes are welded together, the circumferential weld or girt weld, there should be no coating. So you clean this area and then start welding, and then do a field joining at the welding area. This could be a few inch from each side. Project tells you how many inch should be. And there is a pipe tally, and there is a number here. So each pipe, normally these days they are a barcode. So they check it, that how many pipes they received, and they look at the condition of the pipe. If you are a pipeline inspector, the inspector will go and check the pipes. There is no coating damage. If there is anything that we touch up, and the face of the pipe, the bevel angle, sometimes they do the beveling at site. And here, because it's bare, it looks like they will do it. They do the beveling before the welding at site as well. So this is a receiving ground for the pipeline, and then make sure that this areas is not damaged. If it is beveled or tip of the pipe is not damaged. This is the land surveying. So before the way it starts, there would be a surveyor who would go around and start finding, drawing the plot plan. and practically indicating how the pipe should be laid and the route of the pipe. So that depends obviously on the geography of the location. There are mountains, there are valleys, there is trees, rivers, waterways. So that is decided where is the best economical, most suitable way to lay the pipe along that direction. So before they start excavating, they would start taking the tree stumps, remaining portion of the trunk. So they cut the trees and they make the corridor, and then they also remove the tree stumps. Tree stumps is the root of the tree which is already on the ground, so that need to be removed before the excavation as much as possible. And if it is not on the way to the pipe laying, then you just leave it as it is, the tree stump, because those roots will keep the ground, the soil together. And if the flood comes or water comes, if you take the roots as well, the tree stump out of the ground, then it will wash away the ground become unstable. You can see a tree stump here, so only the tree stump is on the line of the excavation will be removed. And you can see here the trenching has been done before the pipe laying. Remember that I always recommended to put the trench at the last moment to do the trench once you bring the pipe along the trench line where you want to excavate. The reason is that there might be water accumulating there over the time. There might be other contaminant going into the trench. So it is always better to excavate when you want to lay the pipe. So this is a ditching trenching, which automatically does that, and it throws the soil this at the side. So up to few inches is the topsoil is on one location, and the remaining soil under the topsoil is would be separated. The reason is that the topsoil is very nutrient for regeneration and for the plants. So when you take it off, you have to separate them and then do it on reverse order. Means the underlying soil would be on top of the pipe, and then the topsoil will cover it, and you do the compacting. So the topsoil is the one that is very useful for agriculture, and hence it shouldn't be mixed with the soil beneath it. Here you can see that the booms are taking the pipe off the trailer and laying it along the line where they want to excavate. This is called stringing. Another picture of stringing where the pipes are laid along the edge that's supposed to be excavated. And this is again another view of that. You can see that the pipes are on the logs, so they don't get flooded, they don't get corroded, because when it's touching the ground, it's because of soil. It's got a lot of moisture, and there's more oxygen at the top, near the soil, so they might actually it is there for considerable time. The pipe might actually have developed some pitting corrosion, so they always put the new pipes on some wooden logs or some other logs, so keep it away from the ground. This is blasting, so sometimes there are rocks and all that, so it's not possible to make a trench with machineries. So they put dynamite and they blast that area. And you can see here there is a pipe bending machine. So sometimes the root is not straight, and they need to be in like an angle, and so the pipe should be bended. And you have two types of bending: cold bending and hot bending. Hot bending is over, say, up to 10-degree bending, and cold bending is up to 5-degree bending. This is another view of the bending machine, pipe bending in the field. And as you can see, the pipe bending is done. Some of these pipes are bended here, and they are on a slope. And you can see here the slope is like, it's not a straight slope, it's like a you can see there is a flat line here, and the reason is that if the water or the flood comes, it doesn't suddenly wash away all the soil. So this is sort of slowing down if any water or flood coming down. Now, these are the side booms, they call it. So once the pipe is welded, you know, for a certain length, depending like a half a mile or a mile of pipe, they welded, still not in trench, and the side boom, several side boom at a particular distance from each other, they hold it and put the whole pipeline in the trench. And the final or the gold weld then is done at the trench, in the trench. The reason is that it's much easier to weld it while it's outside the trench, the spools, than put it in the trench and weld it. Because of access and the welding machine accessibility and the welder's accessibility. And you can see here a closer view. The booms are holding the pipe, and they are all in a synchronized manner. They lift it and put it in the trench. This is a welding machine. This is a trench for welding machine. So this, when you put the welding machine, and this is the jig that goes inside this, so that they hold the pipe together, so they are aligned when they are doing the welding. And this trench is to avoid any turbulence due to wind or rain or anything, so they can do the piping, the welding most of the time. This is another closer view of the jig that goes in, and they're aligning the two pipes so that they start welding. So once it's welded, this jig gets removed and moved to the next pipe, like a sausage. You can see so many welding stations here. They're doing the pipe, and there is a part of this pipe is bended and it still is outside the trench. This is a trench that eventually goes in once all the lines are welded. It's another way of welding machines that they are there. Several welding machines. And again, another view of the welding machines where you can maintain the preheat, or you know, the avoid any turbulence due to wind or snow, rain. The position of the welding machine. This is while inside the welding machine. Here the welders are doing automatically the manual welding. 2 welders, but normally it is done by a machine because it's much quicker and there's a high volume of deposit you can do. Normally they could do a submerged arc welding with several electrodes at the same time, so quickly it will be welded. But here they're doing it manually, and in the back weld manually at the inside of the pipe. This is an electrode and a welding machine which automatically welds, and it goes around the pipe and weld the whole thing inside the trench. And this is, you can see, one of the things that's been done. And then you do the coating. So the coating of that field is done on that area that was not coated, because it had to be welded and then coated. So that's probably around, say, 10 inch or total or 10-12 inch of coating. So this is a pipe, it's all welded, it's closed, the entry or exit is closed so that there is no animal going inside it by mistake, or no dirt going inside it before it's being commissioned or installed in the trench. And this is a pipeline pullback, so the jig goes here, the pipe comes and then push it, and then goes in, hook on it from inside, and then clamp it from inside, and then pull it up so it goes under the waterway. This is another way of a road, bypassing a road under the road. So you can see the sleeves here. There are two pipes going, one big, one smaller, each one under its own sleeve, and then the pipe gets through this and moves under the road. And this is the way it's pulled up from under a waterway or a road. It gets pulled up, and it's normally in this sleeve. This is another location where the jig is fixed into inside of the pipe, and pulling out the pipe from that sleeve. And they call it horizontal drilling, directional drilling. So it goes down, drill it, and then pull the pipe on that way back. This is a pipe going under the another way of horizontal directional drilling. It goes in into the trench under the road, and this is another location where you can see the pipe is getting pulled out of the sleeve. This is another one that is hooked onto the pipe, and they pull back the pipe or drill it first and then bring it back. And here probably guys blasting or cleaning the area before applying the coating. And here coating is being applied locally for any damage or for the welds, and then or for any damage done at the field. This is another coating done at the field for any damage, but normally coating done at the shop, the major part of the coating, but this is for any damage that might have happened. This is another way of coating the after the welding. So there is a wrap, and then that wrap actually works as it's called the shrink wrap or heat shrink sleeve, and then they heat it, and then that will stick to the surface of the pipe. That works like a coating. It's as good as coating. This is a holiday surveying. So this is a high voltage, and it is going around the pipe. It's a ring, and practically if there is a hole in the pipe, there is a coating damage, and one hole is connected to the pipe and one hole is connected to the ring. So if there is a coating damage, a circuit is established, and you can see a spark here. It's called holiday testing, and then you have to repair that areas because you may not be seen by or the hole visually or with any other. It's a very quick way of finding any hole or any unacceptable thinning of coating, so you can repair that area. It's called holiday testing. Again, this is another holiday testing. This is a broom and does it locally, so you don't need to scan the whole thing. You see any area that suspect of coating damage, you do with a broom. So that does the same thing. If there is the coating is too thin or there is a hole in the coating, it will spark, and you can detect that, identify the area and repair it. This is again side boom, and the trench that is created on the pipe lay, they call it right of way. in another angle of side booms, putting the few pipes that are welded together inside the trench. This is again another angle, another pipes they're putting in the trench, and then another angle that they're lifting them on a putting in the trench. Then after the pipe put in the trench, first you do the bottom soil back and then the top soil. So on the same, the reverse order, so you have always the topsoil on the top. So they are burying the pipe now, call it backfilling. This again another backfilling, it's been done. That's the bottom soil. And then you do reinstatement. You put the topsoil around it, on top of it, and level the ground. And now this ground is fully leveled, the pipe is inside, and this is a right of way. And here they do a pipeline cleaning and gauging. So if there is a pipe that is being quality is unacceptable, so they can put this gauging and then they push it up and sort of restore it to the original condition. A pressure test. So this is a recorder, and so it records the pressure against the time, and there is also a temperature gauge normally here. And you can see here it was a pressure test failure because the temperature was at the brittle temperature and the pressure was high. So the brittle to the ductile to brittle transition temperature, it happened. So normally you have to be careful when do the pressure test, maybe pre-warm the liquid or bring the pressure down. And so if it's very cold, the liquid, the water, or the environment is very cold and it falls at brittle phase, then it will have a failure, as you can see here. It's bursted and it's a complete failure without any deformation at all. Cathodic protection, I normally have the negative you connect always to the pipe because this works as a cathode. So anything that is anode, these are the magnesium or aluminum or zinc, and this is called cathodic protection. Or you can use a battery and keep impressing current to the pipe. So as long as the pipe is in negative state, because what happens is if you don't impress current or something else like a sacrificial anode like does not corrode, so actually the pipe corrodes. And how it corrodes is it loses electron, and in order to be stabilized it will react with oxygen and then oxides and then corrodes. So as long as it is in negative state, the pipe, it doesn't corrode because it has enough electron and it doesn't need to react with oxygen for that lost electron. So that's called cathodic protection. The pipe is always cathodic. And CP connection, cathodic protection connection, so you check it and see that there is always a negative state of the pipe. Check the amperage. It's normally 850 microvolt. Potential difference should be there. So always the pipe is in negative state, cathodic state. Measuring the impressed current, how much current is being done. So the amount of current impressed should be along that the electron it loses, and always a bit more. And then you restore it because the topsoil you used, you can do vegetation and then restore the nature. Yeah. and there is always a metering station at the beginning of the pipe, at the end of the pipeline, to see how much was injected and how much was received at the other end. This is for also financial reason, because that would be the amount of gas or oil delivered. And dike to prevent erosion, as you see these dikes. So if there is a slope, if there is a flood coming and these dikes are not there because of the velocity of the flood, and there is no trees here to hold this together, so there will be erosion of the soil. So they put the dikes to slow down the speed of the water if there is a flood coming this way, so the soil will not be eroded. And lockout tagout, when we say lockout, means you lock it, physically lock it. When you tag it out, that means put some warning, for example, for a staff only, or do not touch it or something like that. Here you can lock it. As you can see, there are locks here. You lock it, or you tag it. So this is lockout. And there is a tag also says that do not remove it. So both physical and also pictorial warning. This is a confined space, and the lifeline here, in case somebody falls from the ladder, so he wouldn't be injured. And there's a torch it's having, should have enough light, should have a scaffolding. There should be a work permit for any confined space. There should be gas test, and there should be always somebody watching when somebody entering the confined space, especially on the trenches. The banks might fall, give away, so be careful. Unless they are not being secured and stabilized, you should not enter a trench or a excavation. These are different types of respirators. This is total face respirators, and this to avoid any harmful gases to breathe. This is a grinding. The guy is having an apron. He's also having a respirator which gets filtered air from the back here, comes in, and there is a fan, and his face is also protected. And then sometimes there is a light here to have enough light, and he has all the loaves here. So this grinding is hot work permit. You need to have a hot work. This is another respirator with the full body armor for blasting when you're blasting the pipe. And this is electrical insulating glove, and the thickness of this glove depends on the voltage that they say how much voltage they should be used to. And this is a permit to work. They should be filled in, the location, the timing, and normally each permit to work is for one shift. So once the shift is finished, you take it back to the permit office, and they would renew it for the next shift. They should say what are the dangers and what are the mitigating measures or eliminating measures. Like, for example, there is a danger of hitting your head, or things flying, objects going to your eyes. So you need to have helmet or safety goggles, or there is a danger of gases, so you should have respirators. So this is all checked in, all possible dangers, and then this is issued to the person, then who is allowed to start working. And there is we talk about this. If there is an incident report, injury report, you should fill the form and make sure that there is accurate. Take all the witness statements, what happened, how it happened, and where the guy has gone for treatment, the age of the person, his address, next of kin. All this need to be filled in, because people might forget once the, 1 day or 2 days later what really happened. So it's always better to fill in this form as soon as possible, So to prevent this in future as well, I think we covered all this. Thank you.